Here are your examples for Lesson 7 in Chapter 5. Lesson 7 is about finding distance on a coordinate plane. So in other words, if we had a coordinate plane and we have 2 points on that coordinate plane, we can use the Pythagorean theorem to find the distance from point to point straight, or as some people would say, as the crow flies. All we have to do is find out how many units on the grid system here for that leg, and then how many units here, and we can use the a squared plus b squared equals c squared in order to find out this part here, the c, or the hypotenuse. So you can do this one of several ways. You can use the equation like I've been giving you, where you have that the hypotenuse equals the square root of a squared plus b squared. This is the way that you're going to see me solve these problems. So let's take a look at our first problem here. And one of the things that I want you to notice is that I'm going to always line up the coordinates of the points one above the other. So we've got 3, 0, and we've got 7 and negative 5. So the way they show it here is you can plot this point. We go from the origin over to 3 and then up or down 0, so we're right there. And then of course for 7, negative 5, we go over to 7 and then down to negative 5, and we have a point there. And then once you've plotted that, you can plainly see that you can look at this and count, and we have a leg of 5 here and a leg of 4 here. But I want you to see that we wouldn't really even need to plot this. What we're really looking at is we have our x coordinate here and our y coordinate here. As long as you line them up like this, the key thing to remember is this is not an addition or subtraction problem, it's a distance problem. So you're asking yourself, how far is 3 from 7? So if you think about that on a number line, and the meter sticks are still at the front of the room. If you ever want to use those, just get up and go get one. So we've got the point 7 here on the number line. This would be 6, 5, 4, 3 would be right here. So it's a matter of how far is that? Well, it's 1, 2, 3, 4. And that is where this comes from, because that is the x value. So we have one leg is 4. And how far is 0 from negative 5? Well, that should be really easy. The other leg is 5. So notice that's where these distances came from. So if you'd like to plot this, if you're a visual learner and you want to have a coordinate plane handy and plot your points and do it this way, it's perfectly acceptable. But I want you to understand that you should be able to just line them up like this and quickly see that your 2 legs are 4 and 5. Then all you need to do is plug that into my equation that I gave you. The hypotenuse equals the square root of 4 squared plus 5 squared. And of course 4 squared is 16. We'll put it over here. 5 squared is 25. 16 plus 25 is the 41. So we're taking the square root of 41. And in this case, we've got plus or minus, but negative values don't make any sense here, so we're going to say that it is about 6.4 units from point A to point B, we could call it. Please press pause and do letter C. In this case, they do want you to plot it on the coordinate plane here. I think that's good practice, but if you'd like to also practice doing it without it and do your math over here like I did above, that's perfectly acceptable. Okay, we have a key concept here that is really very close to what I was just talking about up above. So let's take a look at this. The distance d between 2 points, so in other words, this right here, between 2 points, which is a hypotenuse, of course, the distance d between 2 points with coordinates x1, y1 and x2, y2 is given by this formula. Well, you can see that this formula is the distance, or in other words, I was using h for hypotenuse, so if you want to use this, go ahead. D equals the square root of, well, x2 minus x1 is one of the legs, and y2 minus y2 minus y1 is the other leg. So in other words, it is very much like we were just talking about. The distance, or the hypotenuse, is the square root of leg squared plus leg squared, and this is where you get these values from. Now you can do it as a subtraction problem like this, but I think it's easier if you just think about it as distance on a number line and calculate how long is that leg. How far is 5 from negative 5, for example, or how far is 3 from 2, that sort of thing. And you can see here where they talk a little bit about what I just talked about with the fact that the distance formula is just another form of the Pythagorean theorem, as we've been talking about quite a lot. Let's take a look at example number 2. Number 2 says, on the map, each unit represents 45 miles. So we're going to circle that and remember to come back to that later. And then they have West Point, New York is located at 1.5 and 2. Okay, that would be right here. And then we have Annapolis, Maryland is located at negative 1.5, negative 1.5. And then they ask, what is the approximate distance between West Point and Annapolis? So let's circle Annapolis first. But the key thing we want to look at here is we have 2 points. We have 1.5 and 2, and then we have negative 1.5 and another negative 1.5. So really all we're doing is we're asking how far is this from this? Well, if we go from negative 1.5, I'm sorry, positive 1.5 to negative 1.5, you should see that that's 3 units. One way to do that would just put it in the calculator as 1.5 minus negative, make sure you use negative 1.5, and you would get 3. Same thing here, you could go 2 minus negative 1.5. So from 2 to 0 is 2, and then to negative 1 is 3, and then to that half is 3.5. So we have legs of 3 and 3.5. So our solution is to use the square root of 3 squared plus 3.5 squared. And we end up taking the square root of 21.25, and we get 4.6 for our answer. Now, notice that they have 2 different methods here. If you'd like to do it, if you've been doing things with the a squared plus b squared and then subtract from both sides, or well, in this case you wouldn't have to subtract from both sides, you just get the sum of 3 squared and 3.5 squared and take the square root of that. That's perfectly okay. If you want to start switching to this distance formula, which is a form of the hypotenuse equals or leg equals formulas that I've given you, then use that. Use what works for you. But there's one more step to this problem, because we have it's 4.6 units, but every unit is 45 miles. So we have to go 4.6 times 45, and that gives us about 207 miles for our answer. Please press pause and do letter B. Okay, let's take a look at example C. They ask us to use the distance formula, so we're going to use the distance formula definitely. We're going to say D, or if you want to just keep it as H, that's fine with me, equals the square root of the leg squared, which in this case they're telling you exactly how to get it. It's x2 minus x1. So, but I'm going to leave this as leg squared plus leg squared. Now let's take a look at that. We have 2 different points here. We have 5 and negative 4 right here, and we have negative 3, negative 2, negative 3, negative 2. So again, I would ask you, how far is 5 from negative 3? Well, from 5 to 0 is 5, and then from 0 to negative 3 is another 3, so that's a distance of 8. So we're going to have the square root of 8 squared plus, from negative 4 to negative 2, they're both on the same side as 0, so that is a distance of just 2. So we have 2 squared, and if we take the square root of 8 squared plus 2 squared, that's the same as taking the square root of 68, and that would be about 8.2. So that would be our answer to the nearest tenth. Remember, to the nearest tenth, unless they give you some other goal. Please check all of your letter problems with the letter video.